Good morning. My name is Noah Gaida. I am a third year undergraduate mechanical engineering major at University of Hawaii at Manoa, and I'm presenting my project on designing solar panels for sustainable energy in Hawaii. So, to start with an introduction, in this class, we're looking at how we can improve Hawaii's goal to meet 100% renewable energy. Uh, it's a goal that I think a lot of the world wants to achieve right now. Hawaii specifically is a good spot for solar energy to work on because of its position so close to the equator. I did a project on this last year, and the main point was that when using solar panels and trying to get an optimal sun beam angle so that you get maximum efficiency, you want that angle to give you an average of like the most sun you're going to receive from it year round, not just during summer hours or winter hours or something like that. Hawaii's geographical location makes that very optimal, being so close to the equator. In this class specifically, I looked at both a public infrastructure area to install solar panels for, just like Honolulu in general, and also a resort somewhere in the island. Mine specifically was on the North Shore of where we can incorporate solar panels given certain specifications. So, main idea by adopting solar technology now, uh, both commercial and public infrastructure developments can get not only maximum energy output, but they also can get lasting financial returns while actually contributing to a sustainable and climate resilient future. So first area I looked at was the Ala Moana Beach Park. I looked at it specifically because it's a big area. Hawaii, Waikiki, and Honolulu itself is very dense and cramped, so there's not a lot of space besides rooftops to put solar panels, but the beach park in general is a good spot. And you can look at trying to decrease electric energy producing costs for the Ala Moana Center, for Waikiki, for the hotels nearby. That was a good spot. For this project, we were supposed to choose a building, so I chose this recreational center right by the McCoy Pavilion across from the Ala Moana Center in the beach park. So I chose that specifically. It's a relatively small building, lots of trees around because it's in the park. I designed it. The design is in that center column right there in Figure 2. This design was not much critiquing going into it. It was just filling the whole rooftop with solar and seeing how much net energy we can gain. So the solar panels themselves produced approximately 160,000 kilowatt hours. After using some of that energy to produce actually energy for the AC in the building, it came down to about 145,000 kilowatt hours surplus that we have to use for somewhere else, which I thought that's a good look towards supplying, I don't know, lights in the park, Ala Moana Center, somewhere else in Honolulu. It's a good step in that right direction. The next design was looking at Turtle Bay Resort on the North Shore. The specifications included you don't want to people go to stay at that resort for the natural views. You don't want to ruin that. So I looked at solar canopies and I was able to place them in way out spots away from where the people are, in areas that both produced energy and provide shading. So they're multi-use. These produced about 100 or almost above 1 gigawatt hours of energy, which is huge. In that conclusion, which you can see were the rough design requirements. They want a gigawatt hour annual solar energy and no more than 2,500 solar panels. I was like 600 solar panels under that limit and produced the maximum solar energy. So that shows that going into the future, solar panels, but not just solar panels, solar canopies are a great step in the right direction to both providing good energy output and multi-use to making Hawaii a really good renewable energy source for the future.